So let's first get the cosine and sine of this negative 5 pi over 6. We know, let's draw the angle. So negative 5 pi over 6 is this angle. What is the reference angle of this angle? Reference angle, this guy, right? So this guy is equal to pi minus the 5 pi over 6. So that is a pi over 6. So the reference angle is the pi over 6. So you have the cosine of the pi over 6. Now tell me, what is the sine of the cosine in the quadrant 3? Negative, positive, negative, right? So you prefix this negative sign in front of this cosine of the pi over 6. Then, similarly, what is the sine of the sine function in the quadrant 3? Positive or negative? Still negative, right? So you also prefix negative sign in front of this sine of the pi over 6. So now let's simplify. You have the 4/5 times negative square root of 3 over 2 minus I over 2, because sine of the pi over 6 is equal to 1/2. And the 4/5, this is equal to 4 squared times 4 squared times 4, right? You have the 16 times 16 times 2. You need to add the 1 by 2. So 2/5 is equal to 4 squared times 4 squared times 4. So I can write this as the square of 16 times the 2 squared. So this 2 and this 2 cancel. So you should have the So you should have the 2 times 256, that is the 5/12, right? So negative 5/12 times root of 3, and then minus negative, minus the 5/12 times I, and then done. Look at another example. Is the page 628, problem 14. We need to find the fourth power of negative 2 plus 2 times root of 3 times I. So first, let's get the real part and the imaginary part of this complex number. So the real part A is equal to negative 2. The imaginary part is equal to 2 times root of 3. And then we get the modulus. R is equal to the square root of A squared plus B squared. Then you have the square root of the square of negative 2 plus the square of 2 times root of 3. And then get 4 plus, square of 2, 4, square of the root of 3, 3 times 4, you have the 12. So 12 plus 4, 16, and then square root of 16 is equal to 4. And then we can find the argument. So this time I use the cosine. Actually, you can use the sine, cosine, whatever, So cosine theta is equal to A over R, and this is equal to negative 2 over 4. So this is equal to negative 1/2. And then theta is equal to arc cosine of negative 1/2. What is the arc cosine of negative 1/2? What angle? First, what is the cosine of the 1/2? Pi over 3, right? Then arc cosine of the negative 1/2 should be equal to pi minus the pi over 3. So it's equal to 2 pi over 3. Actually, you can use the reference angle to verify cosine of the 2 pi over 3 is really equal to negative 1/2. And this 2 pi over 3 is between the 0 and the pi, which is the range of this arc cosine function. So in this way, we found the argument of this complex number. Now let's get the fourth power of this negative 2 plus 2 times root of 3 times I. So we convert this complex number into the trigonometric form. So we have the modulus 4 times cosine of the 2 pi over 3 and plus I times sine of 2 pi over 3, and then whole thing to the fourth power. Right. So by De Moivre theorem, this is equal to the fourth power of 4 times cosine of 4 times 2 pi over 3. So this is equal to 4 times 2, you have 8. So it's the 8 pi over 3 and plus I times sine of the 8 pi over 3. And now let's try to rewrite this 8 pi over 3 as the sum of a multiple of 2 pi and another angle which is between the 0 and the 2 pi. And we know if you divide the 8 by 3, you will have the quotient 2. And the remainder is the 2, right? So this is how we divide the 8 by 3. Now let me add the pi to the both sides. Just multiply both sides by pi. And then you have 8 pi over 3 is equal to 2 pi plus 2 pi over 3. So now we can throw away this 2 pi because both the cosine and the sine have the 2 pi as the period. So this guy is equal to 4 to the fourth power of the cosine of 2 pi over 3 and plus I times sine of 2 pi over 3. And we just compute this, right? So 2 pi over 3, you see here. Let me see. Actually, for the 2 pi over 3, its reference angle is the pi over 3. Let's draw this angle. And this is the 2 pi over 3. So the reference angle is this guy. That is the pi over 3. And then we have the 4 to the fourth power of cosine of the pi over 3. But the cosine is negative in the quotient 2, so we need to prefix this negative sign here. Negative cosine of the pi over 3. And for the sine in the quotient 2 is positive, so we have the I times sine of the pi over 3. Okay. So now, let's simplify. Then we have the 4 to the 4th power, and this negative cosine of the pi over 3 is equal to negative 1/2, and sine of the pi over 3 is equal to root of 3 over 2, and 4 to the 4th power, this is equal to 16 squared and is equal to 256, right?